right. Hi, everyone, and welcome to the State of IoT Software Development webinar and panel conversation. Today, we're so excited to discuss some of the themes of the State of IoT Software Development benchmark reports created by VDC Research. For those of you who haven't read the report yet, you can find it from VDC and also on the Memfault website. It goes into the inner workings of embedded and IoT development projects across the world with input from over 750 respondents across multiple verticals and regions. It provides insights into project timelines, budgets, engineering tool selection processes, the impact of different technology choices on projects, and the current challenges faced by teams building and shipping embedded devices. There's more insights that we'll cover today, so I encourage you to read the reports. But for this hour, I've got some extraordinary panelists who are very excited to discuss some of the key findings, or at least the ones we found interesting today. So let me introduce our panelists. I'm going to go brief because there's a good number of them, and then we'll dive right in. So first, we've got Thomas Soderholm, who's VP of Business Development at Nordic Semiconductors. Thomas has a focus on the health and wellness markets. He's been with Nordic for over 25 years and has a background in electronics with a master's degree in computers and electronics from the Norwegian University of Science and Technology.
Hello, everyone.
We also have Eva Moscat, who's a software engineering leader. She currently serves as Director of Firmware Engineering at Samsara. Eva has a Master's of Science in Computer Science from the University of Massachusetts Lowell and has extensive experience in developing connected products across the healthcare and consumer electronics sectors.
Hey, everyone.
We've got Nick Sinus. Nick has over 15 years of experience in embedded systems, mobile, and web applications development. In other words, Nick does it all. He is head of technology at Oval, a product development firm based in Nashville, Tennessee, where he leads the hardware, firmware, and software engineering teams. I'll note that Oval is both a Nordic design partner and a Memfault integration partner. So he's got lots of friends around the panel today.
Hello.
We've got Dileepa Prabhakar, who has a background in embedded software and is currently the head of consumer IoT device engineering at T-Mobile, where he leads the product and the engineering teams that deliver branded consumer IoT products, such as SyncUp and 5G home internet gateways.
Hello, everyone.
And last but certainly not least, we've got Adam. Adam is an engineering leader with over 15 years of experience. He holds a PhD in electrical and computer engineering from the University of Virginia, making him by far the most educated person on this panel. After a decade working in medical devices, Adam joined Toast, where he currently leads device engineering, delivering restaurant-grade point-of-sale systems. Welcome, Adam.
Hey, everyone. Thanks for having me.
And of course, my name is François Baldassari. I'm the founder and CEO at Memfault. I'm an embedded software engineer by trade and at heart, although I've been building tools for other embedded software engineers for the past 5 years here at Memfault. Prior to Memfault, I worked on virtual reality headsets at Oculus and helped build the operating system at Pebble. I have a Bachelor's of Science in Electrical Engineering from Brown University. And with that, let's dive right in. So I'm going to start with you, Nick. And I was hoping to talk first of all about the weight of software in some of these IoT projects. We saw in the reports that nowadays hardware products, IoT products are actually, the development of those products is actually dominated by software, with 60% of the total spend going towards software development and 29% of the total spend being specifically embedded software. You work on a lot of IoT projects. So is this a transition you have seen in your organization or on the projects you work on? And how have you had to adapt and change to cope with this transformation?
Sure. No, I agree with that. I think it's also a bigger trend with hardware as well. So we're talking percentages here. I think that hardware, I mean, I might get flack for this comment from hardware engineers, but there's a lot of consolidation with hardware. You're packing more radios, more functionality into the same packages, right? There's as chips get more powerful, the packages are pretty still standard, which means that the layouts aren't getting overly complicated. So there's a lot of efficiencies on the hardware side, but all of that gained efficiency means more work for the firmware team and the software team. So now you're having to build more complex firmware, complex software to accompany for that. So, or to account for that. So, on top of that, I think as IoT devices gain more connectivity, consumers, users, businesses want more touch points from their hardware. So they want more flexibility in how they interact with that device, whether it's through mobile apps or web apps or just a general API. So hardware getting maybe simpler, I'll say that with some caution. Firmware and software getting more complicated. And on top of that, you've got, users just want good user experiences these days, which means you need more complex, elegant software that is reliable and secure and all those things that just add up to more time, bigger teams. And in terms of coping with that, I think training is critical. So we, at Oval, we try and make sure that everyone's getting continual training, continual learning. There's just so much to learn these days, especially with new protocols coming out, cybersecurity concerns, AI, all this stuff means that we have to dedicate time internally for our engineering staff to learn from other people. So it's a big effort, big shift, but it's a lot of fun.
Eva, how has the balance of software and hardware engineering changed in the teams that you've been a part of or managed? Have you seen a trend? Is there more and more software engineers, or is this actually well established in your minds?
I think in my experience within different roles, I've seen different investments. I definitely see a trend of more investment in software. Similar regarding just OTA, a lot of shift towards software as a service, etc. I think outside of like resource investment, one where I've seen it work really well, that transition has been a focus on change management as well. When we think of leadership, if you're like more investing in software, you have to make sure your organization understands where that investment is coming from. To have everyone kind of aligned on this is why we're investing in this way, this is what we're going to do with software, et cetera. Otherwise, I've seen it kind of create kind of a shift between kind of hardware, software, and why software growing this way and hardware isn't. So on top of just resource investment, I think a huge part of this is really change management within organizations as well.
And beyond within the organization, also the business model of the organization, right? Like software has ongoing costs. If you're going to build a big software organization, you have to figure out how you fund that. And that can be challenging also. And I think we've seen a big transformation in business models in the IoT world. Thomas, in the semiconductor side, has the change to more and more software gone all the way down to the semiconductor industry at Nordic? Are you building more and more software?
Yes, and I really want to echo what Nick said initially here. It's if you sort of look at how we progressed over the years that I've been with Nordic, which is a long time, hardware is getting more and more integrated, much more capable. We're integrating more MCUs, a lot more processing power, a lot more features, and with that comes the need for more supporting software. So enable our customers to take advantage of all the hardware that is there in these SoCs, we need to do a lot more on the software side internally. So our software team has grown immensely over the last, I would say, 10 to 15 years. We're dealing with the real-time operating systems. We're dealing with multi-protocol stacks, with more security features, application-specific code, and of course the associated software development tools to enable all this. So yes, software is becoming a much larger part of our day-to-day business as well.
Adam, one of the things that stood up to me was the fact that firmware and embedded software is 29% of the total spend, at least as reported by our respondents. And yet they also said that there were 2 times as many, cloud or traditional software engineers as there were embedded software engineers on their teams. And so it feels hard to square that circle. How can embedded be the biggest item of spend if it's not the largest team? And more broadly, the question to you is, have we gotten to a point where teams are resourced appropriately to tackle this more software heavy and embedded software heavy future? And how do you foresee having to change your teams further to adapt to the change?
Yeah, thanks. So yeah, I've seen this play out. I wouldn't say till the end, but I've seen at least the beginning part of that transition happen in a number of jobs that I've been in recently. I don't think they're staffed appropriately at this point, at least the places I've worked, they've started realizing this. The way I square that in my mind is that a lot of people still budget and resource some of the firmware pieces like they're a hardware project. In other words, they don't have that ongoing cost. So what you see is a lot of contractor or ODM outsourcing of firmware during the initial build, and then a lot of pain when you can't support that coming back, right? So the transitions I've seen are about shifting that over time, right, to something that looks more like that software distribution. I do think we will see that shift over time, maybe never fully even out, but I think we'll see it shift. And for me, what I've seen while in that transition phase is an importance and a need on sort of investing on updatability and the ability to debug things that are in the field, right? Because when you don't understand the code base necessarily that you're building, you have to make that case and get yourself out of the fire to get back to something more sustainable.
You raise so many interesting points that I can't resist but follow up on them. First, maybe a pointed question. Is your firmware team at Toast under the hardware organization or the software organization? And why?
Yeah, you'll notice I told you I'm the lead of the device engineering team. I don't even think that's my official title. I think my official title is hardware engineering team. We recently rolled them in under me. And the same thing happened at my last job that I was at in the telemedicine space. Both times they've rolled hardware and firmware and some of the software that's running on those devices together. Where they've seemed to have an identity crisis is where that top level leader goes. So I tend to bounce around between product and engineering organizations, kind of depending on what makes the most sense. So I do see a bit of an identity crisis there. I am under the product org currently in Toast, and I have a strong dotted line over to the CTO. But I have switched that relationship multiple times over my career.
Dilipa, if I can ask you the same question, hardware, software, where does firmware sit for you? And I'll note, by the way, I'll share my bias up front. I spent 2 years at Meta moving my firmware teams from the hardware organization. I initially reported under electrical engineering into the software organization, and it was a big, controversial political change. But ultimately, I think it led to the right outcomes, at least for that organization.
Yeah, I think meaning just like how we have various layers in cloud and mobile app, if we look at embedded software as okay, there is an application layer where let's say there is more customer focused value delivery. I think that part it makes sense for that to be part of product. But there is a lot of embedded software that's so close to the hardware that you really need to be working together with the hardware team to get things working reliably, and making sure that the rest of the project is not affected, right, by any challenges. So I still think there are some synergies where hardware and firmware need to be closer together, but I think there is a good case to be made for firmware to be part of software on an ongoing basis once, let's say, the platform is stable, so to speak.
And going back to another point Adam alluded to, he mentions OTA updates, debuggability, and in effect, like the long-term sustaining of software. And I think one of the key difference between hardware and software is that software can be changed after you ship. And so historically, firmware was seen as a part of hardware and it didn't change, right? You built it, you shipped it, you were done with it. But nowadays you can change it. And in fact, I would argue you must change it because there might be, first of all, to be competitive, but also because there might be a security problem or there might be a really bad bug. And of course, you should change your software if you can. Eva, I'll direct this at you. How are you dealing with that transition when in the past you might have been once and done, and now you need to continue owning the product long term, and you necessarily need to be resourced differently, funded differently, right? Like, how is that conversation happening around you?
I think I want to touch to what Thomas said. I think I've been fortunate where all the firmware teams that I've led have always reported into the software organization, including myself. And I say fortunate because although every company I've been at has some type of model with ODM, or like you get your hardware and then your firmware comes with it, it's allowed me to build a firmware team that's focused on the sustainability of that firmware. So I think the biggest part is because, again, firmware has to be OTA in order to be able to sustain the product long-term to support the ongoing software features. You need to build out that expertise and that separation of concern between your software engineers and the hardware that supports the software that's running on it. So I think, again, it's just crucial to have that in-house expertise, even if part of it is ODM, to really architect your firmware in a way that can sustain the software and be able to update your firmware to move along with the software as your software needs change for the product.
Love that. Building teams that can enable sustainability or can bring about sustainability. Wish I heard about this more. Dilipa, so we've talked about how there's so much more software in hardware products. Do you expect it to become more common for hardware products to ship sooner in the development cycle and operate in more of a as-a-service model where software features get enabled down the line with the software updates, sometimes even long after launch?
Yeah, absolutely. I do want to caveat that by saying that there needs to be a core feature set that is attractive to the customer, right? When you launch a product, it needs to do at least the basics right. And yeah, I think ongoing value delivery is a key part of how things are progressing. We had the famous essay from Mark Andreessen way back in 2011 about software eating the world. We've talked about that quite a bit today, and that's expanded to all areas. So I see this a lot in the IoT space where there is ongoing maintenance, OTAs, security fixes, but also a lot of features being delivered.
Nick, across your wide range of projects, do you see projects starting to adopt this approach already? Where maybe you might be working with a company to ship the product, but also with a long roadmap of improvements and new updates that will be released after the fact, or is this still more in the theoretical space?
For us, it's very industry specific. So some of the projects we work on are more like B2B products or B2B IoT, kind of commercial. Hey, this is our product. This is part of, we're developing a product for a client that's going to then sell that to another company. that client is paying for a certain level of functionality. I agree with Alipa that at least a core set of functionality where, hey, these things need to be there. If we need to enable some nice to haves a little bit later on through an OTA, that's great. But certain industries, people want that stuff, those features and functionalities ready to go, as it's a selling point for them. It also gets a little bit tricky with, safety critical systems, FDA and regulatory and medical devices. It's a lot of that functionality, maybe not all of it, but a lot of it needs to be go through a VMV process. And you can do an ongoing VMV and roll out more features, but it's definitely kind of gets into what Ava was talking about, change management. So you got to be very careful with how you are managing those features, rolling them out, and being very careful that you're not going to brick any devices if you get a little OTA happy. So yeah, I think that certain industries is very popular, especially in consumer electronics, but in others it's maybe not as popular, or more for just critical updates if there's security issues and things like that.
Yeah, certainly regulatory constraints add complexity to the mix. Adam, you have a lot of experience with that. How often did you end up doing OTA updates? Have you ever added a feature to a medical device via OTA updates? Or was it always worst case scenario?
No, I've been fortunate, at least in my medical background. I've been fortunate to be on kind of the lower end of the FDA's radar. So we've been able to do that type of thing. If you're doing class 3 medical devices, forget it. But we've been able to do some of that in my past. I've done this in a telemedicine company that I was in. We released extra kind of sensors that we enabled new features and kind of smart high-level features across the device. I've also done this. I worked for a stint in the home security market for a company called Alarm.com, which you may be familiar with. And we would actually do this a lot, where we'd have radios. Nest did this actually on their thermostats, right? We would release with radios that weren't publicly available, and we didn't have the firmware all built out. We had verified the low-level parts of the network stack, but we knew we had a roadmap where we wanted to release sensors on there that would support it. And so we'd get the product out and then push firmware updates to enable new sensors that we launched later. So yeah, this is come in handy for me, and I do see it growing over time, but just want to echo the constraints that Nick is talking about on that one too. Everybody's not going to start doing this. It'll have to be specific markets.
Super interesting. And Dilipa and Nick both made the point also that there was a core that had to work. I think something that's counterintuitive or a little bit paradoxical here, or a counter trend rather, is that customers expect a higher level of quality than ever. And we've seen recently some of the AI-enabled device get panned in the press because they shipped a product that was too much of an MVP. And consumers have very low tolerance for that. So there's definitely a push and pull there. Moving on to the next key theme of the report, which is complexity and how to counter it. So as we build more and more software, we introduce more and more complexity to our programs. And in fact, the two most common reasons for delays we found in our survey were complexity of the application, so the software complexity, and technical obstacles. So there were the two things that delayed the programs the most. And we'll also note that we had many respondents mention that their projects now included over 1 million lines of code. So that's a lot of software. So this raises an interesting question. I'm going to go back to you, Nick, and then Eva. What can we do to reduce that complexity? Right? Like, I think a lot of it comes down to speccing the hardware and the trade-offs between minimizing BOM costs and maximizing capability to run more software. Like, it used to be that we would squeeze cents out of the BOM, but nowadays maybe 2 cents off the BOM will add $3 million of software development. And so, what's your take on the balance there I'll start with you, Nick, because you have to spec out those projects up front and have to figure out what is going to cost you how much.
Yeah, no, that's a tough one. For us, it starts with our strategy department. So we have dedicated product strategists at our company, and that is their role, is trying to understand what is the user need of the product. What do users actually want before we start designing anything. Earlier in our company, it was kind of up to the engineering staff to figure out what those requirements were. And we would over-engineer stuff. We would add features and functionality we thought was cool. And like we would do it because we could, not because we should. So our strategy teams reined us in a little bit. They ground the functionality that we are building in actual user needs. So they do user interviews, things like that. So we start there. To make sure that what we're building is the right product. So we're setting it up for success from the very beginning. We also work with our manufacturing department very early on so that we can start understanding, look, conceptually, if this is what we think we're going to be building, what are we looking at in terms of manufacturing costs? Is this going to be very difficult to manufacture? Is it going to be fairly easy? What in terms of enclosures and number of PCBs, things like that. I also think that a lot of companies got very creative over the chip shortage time of how they deal with their own BOMs, right? There's a lot of modularization in PCBs these days. So, one dedicated PCB that connects to other PCBs so that you can swap that, that one module out and slap in a new one if that part goes out of stock. And so we also see that with radios as well. You get a radio that is FCC certified, put an M.2 connector on there, slap it into a board, and if you need to change that later, it's an easy swap out. So, how you approach the hardware from the beginning is also important, understanding your manufacturing costs. And then you have the very easy job of, just maximizing specs once you know your costs, which I'm sure won't change. So yeah, it's super tough, but yeah, for us, it just follows that process of strategy, getting manufacturing involved early and build the right thing from the beginning.
Eva, back, moving this to you, how do you keep the complexity as low as possible, or at least at an appropriate level? And specifically, perhaps, how do we look at trade-offs between hardware and software complexity to keep the overall projects as simple as possible?
Yeah, I think in my experience, I echo what Nick said. You usually want to start with what is the product you're trying to build, and kind of work backwards from that. I will say it depends versus like a new product and a next gen product. I think if we're talking about next gen product, you also want to take into account your current kind of system categorization, I would say. So hopefully you have measurement tools, et cetera, to know the capabilities of your software. So how much CPU does it require, memory, et cetera. And kind of the optimization buffer that you have that you can optimize for, and kind of the strategic foresight of what will be the future needs based on this next gen. What are the features we're targeting? Where's the market headed, et cetera, that you want to leave buffer in when you're considering different hardware. I think the trade-off has always been, at least in my experience, on the software side. If there's a way to optimize it in software and reduce costs in hardware, then that's the strategy that you typically go for, just because hardware has, depending how many units, if you're talking millions, et cetera, for example, in consumer electronics, that typically has a higher cost. So yeah, I think overall in my process, if it's a new product, similar to Nick, you start with your product definition. What is kind of your MVP? Having some form of foresight, at least to where the market's trending and where you think your future needs are going to be, and then making hardware decisions based off of that. If it's your next gen, hopefully you have a benchmark for your current software, and then you can use that foresight of like, all right, our next gen is going to have this, and this is where we see the market. We're going to have to support it for 5 years, 10 years. These are the changes we should buffer for in our next hardware selection.
So if I summarize the excellent points you just made, like first, hopefully you're reusing code between projects, you're reusing technology between projects, which means that you have a baseline, right? And because it's hopefully well characterized, and also you've shaken out the bugs, so the complexity is lower. Number two is you measure from your previous programs. So you know, for example, that in product V1, you had 20% memory, free memory on average. And so maybe you can squeeze a little bit more out, or at least you have some breathing room if you are to build new features. Number three is you forecast the features you're building and come up with an analysis of what resources they might take. But in the end, you'll almost always still choose to cut cents from the BOM and add complexity to the software, because the BOM multiplied by millions is just so much money. Adam, do these 4 points resonate with you? Is that also the approach you're looking at when you do your hardware, software planning?
Yeah, no, they do, with some caveats, right? Like it depends the industry that you're in. You know, I've been in medical industries where our units of sale are lower, right? And then that becomes a little more difficult to kind of manage. And we would add hardware specific things to give us a boost, because it actually makes sense from a cost standpoint. You do have to kind of think about flexibility when you start adding specific hardware features, for instance. But yeah, I would follow the same thing. I would say, the way I talk about, you know, next gen products or whatever, and the way I approach that, even if it's a first gen product, I look at it as building a hardware platform that you want to build on. So for me, the most important thing is you're gonna have a cost on that first gen product that is uncertainty and risk and all of those other things. And kind of depending on the industry and business you're on, you can kind of decide to lean towards well, I'm going to risk that I won't have enough horsepower, for instance, to do what I want to do 5 years from now, or risk the BOM cost that you're going to have. But the important thing, I think, is that you're setting yourself up for that second iteration, or build upon that platform across product lines, so that you can have learnings and that you can have a stable platform. You're not blowing it up and starting over from scratch next time you do it.
As an embedded software engineer myself, I always ask for more flash. I can never have enough flash memory. I always run out of code space, and I've seen 6 months long projects trying to squeeze 20 more kilobytes out of the flash. Moving to you, Thomas and Dalipa, to talk about what everyone has been waiting for, AI. I was really surprised that I think about 43% of respondents said that AI was already part of their current projects. Now, it's worth pointing out that doesn't mean that it's at the edge, right? It doesn't mean that AI is in the firmware, in the hardware, but nevertheless, it's a really high number, and it happened very quickly. So starting with you, Thomas, how do you see this changing the way people build and maintain IoT device? And what impact do you think it will have on hardware selection, for example?
Well, I think it's no doubt that ChatGPT has sort of raised the bar, right? So everyone's talking about AI. I'm a little bit careful with AI, to be honest. I like to talk about machine learning and connectivity and what's happening at the edge, rather than go all artificial intelligence and Terminator. But I think there's no doubt that we need smarter edge devices. First of all, there really isn't enough energy in the world to run everything in the cloud, and to sort of be more energy efficient and sustainable, we need to use less bandwidth when we transmit data using connectivity. Connectivity with machine learning gives us low latency, sort of real-time response at the edge. Talk about cost. Edge computing really sort of reduces the need for this massive cloud infrastructure, right? Also, when it comes to security and privacy, not having to transmit sensitive data to the cloud is beneficial. So there are loads of benefits to doing some machine learning, some intelligence at the edge.
And conceptually, it feels like a perfect fit for embedded and hardware. You spend all of this compute upfront doing the training of a model, and then you spend a very small fraction of the compute actually running the model to execute the operation. And so, of course, we're not going to get a large language model on an NRF53 anytime soon. But the concept of spend a lot of compute training and then a little bit of compute executing is a perfect fit, I think, for the kind of edge devices that we've all worked on. Dileepa, what exciting AI applications have you gotten to see? Anything that stands out? And where do you see the most potential for AI at the edge?
Yeah, I'd say I think some of the most obvious ones are image-based, right? So, excuse me. So you have a lot of these security cameras, and you have seen valid use cases. There has been a swing back and forth, running AI on the edge, running classification models on the edge, and then going back to the cloud to do all the inferencing again, right? So I think the longer term trend, like we just discussed, is running inferencing on the edge. But I'm also looking for a future where you have all these hubs, smart home hubs, that hopefully will mean that there is less of a reliance on cloud connectivity and more capabilities, including AI type capabilities running at the edge in your homes.
Yeah, in our kind of preparation meeting, Eva made the great point that she wasn't so surprised by the percentage of projects with AI because, as you said, Dileepa, any device that does image processing is increasingly moving to AI methods, and same thing with audio processing, right? And there's a lot of devices out there that do audio video processing, so I think we're going to see that happen very, very quickly. Another topic that's top of mind for me is, in-house developed code versus open source. I think as someone who straddled the software firmware world, I've always been frustrated to some extent at how much reinventing of the wheel there is in the hardware world. I remember implementing my own linked lists, very basic data structures in C because the jobs I had didn't allow open source, and there wasn't really a culture of open source in the embedded industry in the past. And yet it's clearly changing. There are projects like Zephyr who have increasing momentum. FreeRTOS was a partially open source model before that. And our survey showed that 45% of code used in project was in-house developed, but almost 30% was open source. So, starting with you, Eva, where do you land on open source versus not, and sacrificing potential customizability, pardon me, and even maybe some security, as we've seen recently with open source projects, versus the speed, efficiency, and frankly, the pooling of resources that comes with open source? What's the place of open source in IoT?
I favor hybrid approach. So I think, to your point, I've also experienced a lot where proprietary tools are created, and to be fair, a lot of times they're created because at the time there wasn't an open source tool, and then the company grew out that tool, et cetera, and now it's so hard to move away from it. But I'm definitely on the side of do not reinvent the wheel if we don't have to. I think where I lean towards proprietary tooling is more if it's like a differentiating feature. The tooling revolves something around IP sensitivity for the company, or like you mentioned, security. And I would say security, there's a few caveats too, because I do find open source now is getting a lot more support around security. And once you have a big pool of people focused on making this thing secure, oftentimes that ends up being more secure than your proprietary tooling. But I think to answer your question directly, I'm more on a hybrid approach. I would prefer open source if, again, the thing we're trying to create a tooling for isn't IP sensitive to the company. And licensing matters a lot. So working with your legal team just to make sure that the open source tooling you're using doesn't have any of the tricky licenses.
Right. We've all had to talk to a lawyer about the GPL and making sure that we scan our projects for that. Nick, what's the place of open source in your work, and what's your how do you weigh those trade-offs?
Yeah, as an agency, clients are paying us to be as efficient as possible. So we try and leverage open source as much as we can, with the big giant caveat that Ava brought up, which is licensing. So we just want to make sure if we are pulling in open source libraries or any open source code, that we're very careful about the implications that brings to a client project. But yeah, we love Zephyr. Zephyr to me is a huge game changer. Being able to leverage drivers that have been written either directly by the manufacturer or have already been tried and tested. We've had projects go from where we're picking parts that we know have open source drivers for things like accelerometers and temp sensors and things like that really just take. You're moving from doing firmware with a logic analyzer and hand rolling a driver that would have taken days to weeks to verify several ICs to, hours now. So it's just configuration over a lot of coding, which is very powerful for us as a firm, and being able to use client budgets more efficiently. So security is also a huge one. Same. I also agree with Ava there, that it's kind of a double-edged sword, right? If you're hand rolling a lot of your security, it's almost security through obscurity. Whereas embracing open source code that's handling secure features for you, you're able to leverage that kind of crowdsourcing of testing and bug reporting and fixes. So you have to kind of weigh the pros and cons there, depending on what your application is and what your product is. And, there's also, again, with medical, you need to be very aware of software of unknown provenance and provenance. But overall, we really love open source software and try to use it as much as we can.
Thanks, Nick. Super, super interesting. And I'm also a huge fan of Zephyr. In fact, Memfold has been a member of the Zephyr project for a while. And I even myself had 4 pull requests into Zephyr last week. So I'm big fan. Moving on, another topic within the report was software maintenance in the field. As you can imagine, I have more than a small amount of interest in that topic. So many interesting insights there, but I'll start with this one. The average expected useful lifespan of the devices was about 8 years. I think that's a long time. 8 years is a long time. And for folks who mostly think about consumer electronics, 8 years feels crazy. But of course, if we work on more industrial devices, it makes perfect sense. Given that the projects themselves take 16 months to ship, right? The difference between how long you work on them and how long they stay in the field is a very interesting ratio. So it raised the question of how do we do maintenance in the field, especially as there's more and more software, which can be updated and can change over time. And I'll start, Adam, with you. One of the things that was really surprising to me is still today, the most common way to measure software quality post-deployment was customer bug reports. In other words, many of the respondents didn't know how their product was doing until a customer picked up the phone and complains, right? So of course, customer feedback must have a place. But what do you use? What do you see as better measures, or at least additional measures of quality that we should consider?
Sure. And yeah, customer feedback is always, top line, right? It's the thing you use to to give the high level, low specificity, are we doing our job right? Right. If we don't have that, something's gone wrong. But the thing I would counsel everybody to avoid is like when that goes wrong, trying to get any more data out of your customer reports is normally a fool's errand, at least for me. Doesn't give you any specificity other than like 1 to 10, good or bad, right? You can't figure out what's causing it. So, so look, I mean, we're Memfault users as well, right? So we kind of believe in the approach of collecting specific metrics from those devices, whether it's crash reports or errors, or things along with performance analysis, and trying to figure out how many of those incidents we have and how many tickets consequently get opened for our software team. If we're spending a lot of resources with bugs that we find in the field and verifiable bugs that then we have to go fix, that tells us something about our quality, whether it's the quality of the end product or the quality of the process of producing that product, right? If we're having to touch it a lot, that's not something we want over those times. So
yeah, I like to talk about, the iceberg of customer experiences, where you see the tip of the iceberg, which is the 3 people who send you an email that, as you just said, basically says it doesn't work. And if you're lucky, they say why it doesn't work. Like, what does it mean to them not working? But oftentimes you just get an email that says it doesn't work. That's the tip of the iceberg. And then, of course, below the iceberg is the overwhelming majority of people who experience some issues with your device every once in a while, but will never bother to even send that email.
I'll even add the thing that makes that worse is that you'll have someone who experiences a few things that they don't report, then they experience said new thing. They go to report and they conflate that issue with the 3 others that they've been having that have never hit their target, right? So you get misinformation about exactly what's going wrong, and it's very hard to draw the dotted line between them or actually get root cause analysis, because you think you're tracking down one issue, but you're tracking down 3 that have all been kind of low occurrence. So,
and I've also seen the opposite, where you hear customers say 10 different things and it's all the same issue.
exactly.
There's no single rule. You can't say divide by 10 or multiply by 10 to get the true issue count. It's all over the place. Thomas, on the semiconductor side, you have an even bigger challenge, which is that you're at arm's length from the devices, right? Your chips end up in devices who end up in people's hands. So how, what are the measures of quality in your case? Or how do you think about understanding how the chip performs in the field and whether there might have to be changes you make to the SDK or to the silicon in the next revision? How do you think about that?
Yeah, I actually want to look at this from let's say the consumer customer perspective, right? So me as a consumer, I really want to echo what Adam said. It's critical that sort of customers have a good experience, right, with your products. So from my point of view, waiting for the end user to tell you something's wrong and for you to fix it, that is a little bit backwards. These days, if it comes down to my PC or my phone or whatever, I do expect that to have rolling updates and bug fixes along the way without me finding out personally that there is an issue. So whatever we can do to have to sort of measure the software quality on the backside and do bug fixes in the background without the consumer or the customer themselves sort of having to go through the trouble of reporting it, that would be the preferred way for me. And I think as Nordic as well, as a semiconductor provider, obviously you can't change hardware, but you can obviously change software and do things in your SDK as we do every day. Having means to find bugs and have them reported without touching too many end customers and having aggressive customers, that would be key, right? Because we all know that happy customer is a returning customer. So whatever we can do in the background, that's to sort of understand the health of the devices that we put in the field is crucial.
Thank you. And I think that we, sometimes I'm guilty of thinking too much about it from the engineer's perspective, but you're absolutely right that thinking about what does the consumer, what does the customer want on the other side of this relationship and what might make for the best experience for them is really important. Speaking of, issues and software quality, of course, a really big topic is cybersecurity. I'm going to go to you with this one, Dilipa. Regulators are increasingly scrutinizing IoT security, I think with good reason. In the surveys, however, a third of respondents stated that they don't think they are adequately able to detect security defects. So, what has been your approach to security? Have you had to change it in this, increasingly complex era of software at the edge? And do you foresee more changes in the future?
Yeah, great question. I think cybersecurity is just a very complex topic, especially for connected devices, which all IoT devices are. The approach that I've seen work is being upfront about implementing security best practices, starting with using some things as simple as safe functions, right? You have safer versions of common functions in use, right? Starting with that, but actually getting a cybersecurity analysis done should be part of the mix versus like Nick mentioned earlier, security by obscurity, not a great strategy, right? And then, take advantage of the fact that these are connected devices. So when we talk about observability, what else can you do, right? To make sure that you get leading and early indications of things that are unexpected, right? Some sort of anomalies, right? So if you can do that, that would be a big help for you. And lastly, I think we talked about open source software earlier, but just generally having traceability of software, software supply chain, so to speak, having some effort put into that as part of your cybersecurity review, I think is a must-have in this age.
So cybersecurity and defects, software defects are two things we try to find and try to fix as quickly as we can. And yet in the reports, we found that it's common for it to take weeks, sometimes even months for most companies to identify and find fixed faults. Something that was, I think, contradictory is that they also felt like that was okay. Or at least, the fact that it takes weeks and months, and also the respondent says that the response time feels right to them, feels like, there's something there that I can't quite unpack. But Eva, starting with you, what do you think orgs should aim to when it comes to finding and fixing issues? How quickly should they be able to do that? How what has been the best things you've seen in order to improve those times, and how do you think about that more broadly?
I also found that super surprising in the case study. I think ideally you want to have observability tools. So as a business, you discover the defects before your customers do, or at least you have indicating signals that something is wrong, which buys you time in terms of the fix. I would say in an ideal situation, we're talking days. I know with firmware, it's difficult when you think of OTAs and all the testing that it involves to make sure something doesn't break. But I think to me, the main differentiator there in helping your mean time to resolution is really the tooling you have around observability. And how good of not just tooling, but the metrics you're tracking, are they giving you the right signal indicators to let you know how your software is doing, again, from the customer perspective? Because you can be tracking certain, I don't know, software performance, et cetera, but they're not necessarily impacting your customer base. So I would say you have to make sure your observability tools are tracking the right amount of metrics that give you the signal indicators that you really need in terms of, is your product doing what your customer expects it to do? And hopefully by having that, you're able to catch things Even if they leak into your customer base, you've identified it earlier on. So by the time your customer's complaining, you're already OTAing the fix type of thing.
In an ideal world, it doesn't take a Reddit thread to find out that there's a problem and then spend a month fixing the problem. By the time there's now a dedicated subreddit to the problem that your customers are experiencing, right?
Exactly.
Nick, you know, here again, I think the range of projects you see is interesting, right? Like, do you offer an SLA to your customers in terms of resolving issues? Like, how do you think about your ability with so many different devices, so many different firmwares and types of connectivity to resolve issues quickly? What do your customers expect in the first place?
We could offer an SLA at a price. That's a possibility. For us, it starts because we're Memfault integration partners. We've put Memfault in several client projects already. It's for us, it's one of those conversations where it has to happen up front, where we say we're going to get started on the firmware, and we need to have a plan for when there's firmware issues, when there's features that aren't functioning how you want them to function. You know, we need to capture that stuff early. Memfault's a great way to do that. You can hand roll it yourself, and your software team can reinvent the wheel of what Memfault does if that's what you want your software team to do, or you want us to do. But that's a lot of time, that's a lot of money, and why do that when there's a great product? And so what we tell customers is it helps us sleep at night knowing that if there are issues that are coming up, that we're able to get ahead of those, we're able to find them as early as possible, and we can know down to the line of code where that issue is occurring on. So it does allow us to turn around fixes a lot faster. I do think that the overall topic of why firmware fixes are lower than software bug resolution is a bigger, more complicated topic, just because there is so much more testing and QA. Like, the stakes for firmware fixes are so much higher. You can, you know, roll back your web application changes and redeploy. You can do an expedited mobile app upload and push that update out. You could very well push out a firmware fix that has unintended current draw issues, and now your device that's supposed to draw microamps is drawing milliamps, and now your device is dead before you can push out another OTA. So it's very it's a complicated topic to talk about time to resolution. I think the big thing is identifying it early, and knowing what the issue was, so that then you can do your regression tests and have a lot of confidence. And then when you push that OTA out, that it's going to work, and you're not all of a sudden going to have a bunch of a whole fleet of dead devices on your hand.
I feel like we could spend an hour on that topic alone, but sadly we're arriving to we're getting to time. So I'm going to ask each of you to briefly answer the question, you know, what do you see as the biggest challenge or maybe opportunity in IoT development projects today, and how do you think about changes you want to see happen in the future? I'll call on each of you to respond, and then we'll go to a few audience questions that have been submitted and wrap up. I'll start with you, Adam. What's the biggest challenge and opportunity? What are you thinking about looking to the future?
Sure, and this is actually fairly relevant to what we were just talking about. I mean, I think the biggest challenge here is observability in these products. As Nick was stating, we don't, you know, push out a failover device for every device that's in the field, right? The stakes are high, and observability is kind of key there. I'll also echo something Ava said, which is I think people tend to go, well, we have observability, but what type of observability you have is really, really important. One thing I've seen break down in the organizations that I've been in is cross-stack observability. So we'll get like one team that does great observability at one layer of the stack, but then we can't trace the cause of it because it may have been above or below, right? So I think just the field of observability and understanding what needs to be there in order to generate root cause analysis quickly is one of the biggest challenges in the field right now, and something that I think will go a long way in the next few years.
Tracing a request from the firmware, from the hardware to the firmware, to the connectivity stack, to the clouds, to the database, or whatever happens up there, back down to the device with a response, and the whole life cycle of an interaction between these very complex systems in their own rights is a mind-bogglingly complex system.
Yep.
Eva, I'm going to ask you the same question. What's biggest challenge or opportunity, and what are you thinking about looking ahead?
Can I just steal Adam's?
You can
No, I'm
say
kidding.
+1. Yeah.
I just want to echo what Adam said. I think like measuring or creating your observability around your customer functionality and making sure that goes through your whole stack is important. And I see it as a challenge I've seen in my various roles. And I think that also translates to the challenge we talked about a little bit earlier of where do you invest in software, in firmware engineering. I think starting there, that kind of ripples through your whole like architecture of your software stack, which then ripples through your observability and how you view it. So I think the biggest challenge is finding that balance and making sure that you're not under-investing in the sustainability of a hardware platform, and you're looking at your product as an entire software stack that includes firmware that supports the hardware that's going to be out there for years.
Thanks, Eva. Going to you, Nick. Same question.
Yeah, in terms of challenges, I would say the number of hats that we are asking embedded firmware and embedded software engineers to wear. It's a lot. It can be overwhelming at times. They need to understand hardware. They need to understand concurrency. They need to understand interference and networking, and now AI, cybersecurity. It's a lot. And so what's key there is, in my opinion, is a lot of the things we've already talked about, which is try not to reinvent the wheel, to avoid the not invented here syndrome, leverage open source code when you can. Training is critical, staying up to speed, not only on trends in the industry, but just making sure that you're proficient in the right tools that could save you a lot of time. Automation is killer. Invest in your CI pipeline. It can really save you a lot of pain in the future. But other than that, I would just say be thinking about your future self and what you have to support long term, because it's easy to get heads down and try and solve problems and crank out fun features, but all those features have to be supported long term, especially if it's 8 years. It's things that you will need to live with, or for us, our clients need to live with, and so we want to set them up for success there, and make sure it's stuff that it's features and functionality that work well, and that are reliable. And we haven't built a overly complicated thing that users don't really enjoy using, right? We want to keep it simple and elegant. And that starts from the very beginning when you start to architect and write your code. So
be kind to your future self. Like that could be a tagline. I'm going to feed that right to a marketing team. Thomas, what's your kind of recommendation, and what do you anticipate as the big challenges or opportunities today?
Yeah, I think one of the clear challenges is that you sort of look at what's happening right now and what's happening in the near future with IoT, is that it's not acceptable anymore, right? To just buy and use and throw away stuff. So things need to be built to last. They need to be designed to last. They need to be smarter, more sustainable. They will have more demanding applications, more advanced software. So there's sort of this inherent challenge to ensure that you create, well, basically tomorrow's technology today, right? And I think with that, you need to make sure that you leave room for software improvements when you choose your hardware platform. You need to sort of build for that future functionality. Get products into the market early, evaluate performance, device health, obviously, and then make quick software fixes along the way. I think that's the way.
And last but not least, Dilipa.
All right. Yeah. And say a couple of things here, right? At an executive level, I would say we need a bit more persistence and patience when we build hardware products. I think we are all spoiled by the expectation of mobile apps and software, right? Where you get stuff instantly, relatively speaking. So yeah, there is that opportunity, let's say, to invest in persistence, keeping the momentum up. And for actual project teams, I'll say invest in automation. Nick mentioned this, right? But there is a lot of low-hanging fruit. Integrate debugging tools early into your product development lifecycle. Keep using them all the way through. So that's where I would put the emphasis on for project teams. There are a lot of companies that are still doing a lot of things manually.
Some really, the themes are clear, right? Like be kind to your future self. Think ahead about what sustaining is going to look like long term and build analytics, observability into your projects. Leverage open source if you can, and don't just think that it's done the moment you ship. There's still a long road ahead after that. I'll touch on a couple audience questions and then we'll wrap up. One of them, a little bit of a low-level question, but I think some of the engineers on this panel will enjoy talking about it. So you might have heard that CISA, one of the U.S. government cybersecurity agencies, is pushing for memory-safe languages to replace C and C++. That's actually, I think the White House even wrote a paper on that. I never thought the White House would talk about C and C++, but here we are. Given that almost all IoT development is written in C and C++, is this realistic? Are you, I'll start with you, Eva. Are you planning on listening to what the White House is trying to tell you and ditch C and C++ in your projects moving forward?
I think there are a few languages that are aiming to do that. I know Rust has been picking up in terms of like the IoT space and hardware products in general. Is it realistic like within the next 5 years? I don't think so. But I think eventually with the adoption of these new languages, I can see a world where new products start coming out that aren't C and C++ based. I think it would have to, we'll see that shift more when the semiconductors also shift that way, if it's even possible.
I'm amazed to say that Memfault has a handful of customers who write their firmware exclusively in Rust already.
Nice.
In production out there. And I find that very exciting as, I've written C my entire career, but there needs to be something new. The software has gotten so complicated. There really does need to be something new. We had so many questions on the AI that maybe I'll give us an opportunity to talk about that a little bit more. One of the questions was, and maybe Adam, you can talk about this. What's the state of the art in terms of Edge AI for you? Have you seen Edge AI applications that you're really excited about and potentially are looking forward to using in your programs?
I would say not. So in my capacity at Toast right now, I haven't seen a lot of use for AI, but I will say, kind of echoing something someone already said about the current state of the art with AI, I see it a lot more in video processing and audio processing, right? So I think the first places we see that come to light are going to be in video and audio. I've actually seen a number of products that I would call AI enabled already for this. I just think we think about it a little differently today. All of these don't have like one of the NVIDIA Jetson chips running where they have something super scalable and configurable, although some do. But a lot of them are running AI neural nets that are trained and almost hard coded in the hardware. Therefore, I was in telemedicine for a while, so people and speaker tracking, most of those things are AI algorithms that are already in there. And there are companies that will release hardware chipsets that aren't really ASICs. They have their own firmware on there. It's just a proprietary blend of stuff. And you can kind of get it across the range of super energy efficient and frankly not all that functional to something that's configurable and has good horsepower, but will drain your batteries if you've got a battery powered application. So I see it coming in there first, and I've seen some good work. Just look in the video conferencing space. They've been doing this long before AI was a thing. And actually, if you want to look at someone kind of leading the way, I think of where it might go eventually, you can take a look at what Cisco did. So over 6 years ago, they were using Jetson products. They didn't advertise this in their systems so they could update their algorithms as they're in the field. And I think that worked fairly well for them, given the big caveat of it's Cisco, so you're paying through the nose and you're in kind of a closed ecosystem that I think, by evidence that we're on a Zoom call today, hasn't always worked out for them. But yeah, there's a lot of opportunity there. I just think it'll start with those.
And the last audience question before we break, I'll go to you, Nick, which is, so one audience member says, I've heard that OTA capability should be the very first feature that a company puts in place for every project. I certainly believe that, but I'm curious. So what the person asks is this true? Question one. Question two is, why is that? And then question three is, what's the number two on your list after you have OTA? And, talking about generically across projects.
So yes, OTA critical these days. And it needs to be bulletproof, right? That's the other thing is be very careful hand rolling bootloaders, custom bootloaders. Part of the reason why we love Zephyr is MCU boot, tried and tested. Just configure it right and test it before putting anything in the field. But yeah, OTA, critical feature. And I think that there's even regulations and at least guidance about needing to be able to support updating your firmware for certain devices these days. So pay attention, put your lawyer hat, another hat people have to wear, or put your lawyer hat on, and be aware of the regulations around putting a device in the field and making sure that that you can update it. So second feature, good logging, good observability, put Memfault in there. So for us, one of the big points of maybe not contention, but where we see a huge need for good logging, OTA, and Memfault is if we are working with another team or if a software team is working to interface with a hardware device, and there's a lot of back and forth of like, well, we sent it this command and it locked up, and well, we can all log into Memfault and go, oh, okay, we know what happened. Here's the issues, and we can resolve things a lot faster than having to, share screens and get on a Zoom call and try and debug things remotely from one team to the next. So, yeah, I think those are the things that we normally start with.
Thanks, Nick. And I'll note that with the CRA, the Cyber Resilience Act in the EU, you're going to need to have OTA in order to sell your device in the EU starting in 2026 or 2027. So it may become much more than a best practice, but really a requirement. And with that, I think sadly our time is up. We've already gone a good amount over. I'm so thankful that you could spend this hour and 15 minutes with us. I found the conversation extremely fun and stimulating. I wish we could do this for much longer, but we all have day jobs, of course. So Adam, Eva, Nick, Thomas, and Dilipa, thank you so much for your insights, your time, and the experience you were able to share.